We are still in Laplace transform. We will talk today about some cases where you can use what I call advanced Laplace transform. These cases you may need to use partial fraction expansion in order to make the solution possible and convert your solution from S term into T term. In order to clarify those concepts, let's start with an example first that will have the simplest case of partial fraction expansion when it is embedded in the Laplace transform initial value problems. Then we will discuss more details about all types of partial fraction expansions that you may use, how to differentiate between each method or case of partial fraction expansion, and how to deliver your final solution as needed. Let's start in unusual way with an example. So let's say you have an initial value problem in this form: y double prime plus 4y prime plus 3y equals e to the power of t. And the initial conditions for this problem: y of 0 equals 0 and y prime of 0 equals 2. Knowing that, let's transfer this form of equation into the S term. So we can say Laplace will be distributed on each term of the left hand side and right hand side of the equation. Laplace transform of y double prime plus 4 Laplace transform of y prime plus 3 multiplied by Laplace transform of y equals Laplace transform of the function e to the power of t. Okay, as we learned in the previous lecture, Laplace transform of y double prime can be represented as s squared multiplied by y, which is y of s, minus s multiplied by y of 0 minus y prime of 0 plus 4 multiplied the Laplace transform for the y prime can be represented as s multiplied by y of s minus y of 0 plus 3 Laplace transform of y of t can be capital Y, which is y of s, equals e to the power t. Let's go here on the side. We saw previously in the Laplace transform table that the Laplace transform of e to the power of at equals 1 over s minus a. In this case, e to the power of t, which is known as e to the power of 1 t, so a in this case is 1, so it can be 1 over s minus 1. Now going back here, we know from in here, from the initial problems or the initial values, y of 0 is 0, which make this term as 0. Y prime of 0 is 2. Y of 0 can be eliminated in here, and in this case we can continue our solution. If you do the math for the left hand side of the equation, you can find the y of s, which you are looking for. So y of s will be 2s minus 1 over s minus 1 multiplied by s squared plus 4s plus 3. Let's extend this line. Okay, that's the, let's say, half of the solution for the problem. Now the next step is how to make this form, to be in terms of y of t, so that we have a solution in terms of t. That's what we want. In terms of s is not enough. So the easiest way is to use the partial fraction expansion. What you do, so from here you take this term, you put it on the left hand side of the equation, 2s minus 1. Of course you will try to solve this quadruple equation. So we have s minus 1 as it is, and finding the roots for s squared plus 4s plus 3 gives you s plus 1 multiplied by s plus 3. So now this case, as I mentioned in the first of the lecture, there's cases for using the partial fraction expansion. This case is called distinct roots case. So we can call this case number 1 distinct roots. Based on the distinct roots, you know what to expect as you are solving the partial fraction problem. So now each one of these 3 terms in the denominator should be assigned for a certain variable. So we can see here a divided over s minus 1 plus b divided over s plus 1 plus c over s plus 3. Okay, now we do the, let's change the color, we do the cross multiplication to be able to unify the denominator for the right hand side and the left hand side of the equation, so that we can equalize the denominator for both sides of the equation. Doing that, we get the left hand side numerator to be 2s minus 1. That equals to a, it will be in the numerator for the first term, a multiplied by s plus 1 multiplied by s plus 3. Then you have plus b, the second term, multiplied by s minus 1 multiplied by s plus 3 plus c multiplied by s minus 1 multiplied by s plus 1. Now this is important. The challenge in here, and the whole point of the partial fraction expansion, you need to find your a and your b and c variables, so that you can plug it back in here and be able to convert based on Laplace transform table. You can convert each of those terms in terms of t and find the solution. And that's your ultimate goal of doing the partial fraction expansion, because in this form it is hard and tedious process to convert that form into y of t form. Okay, moving forward. Now don't be afraid that this equation could look like lengthy. There's an easy trick that will solve your problem. So as you can see here, these equations are in terms of s, right? So what you can do, for example, to get rid of this term and this term, you can assume s to be 1, since 1 minus 1 will be 0, so you will clear out this term, and s minus 1, so 1 minus 1 will be 0, you clear the second term. Then you have here the values of s on the right hand side and left hand side. You can easily find a. Okay, let's do that. What I usually use, I say at s equal 1, what will happen? Compensate each s in the equation in the value of 1 and see what happens with you. So if you do the math, you will get 8a equals 1. So a equals 1 over 8. That's value number 1. In the same manner, we can say at s equals minus 1, what will happen? You will have minus 4b equals minus 3, and this will lead you to b. b will equal 3 over 4, and that's value number 2. Then lastly, assuming s equals minus 3, plugging that back in the equation, we can have 8c equals minus 7. From that, we can find our value of c to equal minus 7 over 8. Okay, that's perfect. Let's get ourselves some space here. So we get the value of a, b, and c. Let's go in here. So knowing those values, we can say that y of s equals, let's go back to white in here, it equals a multiplied by 1 over s minus 1, which is in here. So this can be 1 over 8 multiplied by 1 over s minus 1 plus b equals 3 over 4 multiplied by 1 over s plus 1 plus c multiplied by 1 over s minus 3. So minus 7 over 8 multiplied by 1 over s plus 3. Okay. Now going back to the table, Laplace transformation table, you can find that this value and this value and this value can be represented. Let's say 1 over 8 will be as it is, 1 over s minus 1 based on the Laplace transformation multiplied by e to the power of t plus 3 over 4 multiplied by e to the power of minus t minus 7 over 8 multiplied by e to the power of minus 3, and this is our final solution called as y of t. So this is how you solve advanced Laplace transform initial value problem using the partial fraction expansion if you have case number one, which is distinct roots.